I just started the recording of this session. As we discussed in risk management, firstly, we plan for our risks. We do a variety of planning. We develop the strategy. We find the methodologies. We talk about different categories of the risks that we are going to dig deep. And once all the planning is done, the next step is risk identification. It talks about to identify all the project risks and identify them as early as possible. In fact, the project manager and his or her team start identifying the risks the day project manager is assigned to the project. We not only try to identify the individual risks, but overall risk to the project. For that sake, we do many different activities. We talk with the stakeholders. We also do some research, some document analysis, literature review, or even sometimes talk with those people who are not even stakeholders just to identify the risks. We can use variety of different techniques in risk identification, including brainstorming and its different variants like brain writing or round robin, so on and so forth. Checklist analysis to identify different risks, interviewing the subject matter experts, root cause analysis. The purpose of root cause analysis could be, okay, we identified one risk. How can we identify, and we identified its root cause. How can we identify other risks whose root cause is the same? Similarly, we can go through our assumption log and analyze it, because if you remember, in the start we discussed that the assumptions, when they are not true or not proven to be true, in that case we say that assumption has become our risks. Similarly, our limitations and their analysis of enterprise environmental factors using SWOT technique, that is looking on internal and external risks. Anybody of you use SWOT analysis? Yeah, so it could be used for different purposes. And one of the purposes is to identify the risks. The people who don't use SWOT analysis, obviously they know that it means strength, weakness, opportunities, and threats. Strength and weaknesses, they are internal to the team, internal to the organization. Opportunities and threats are normally, sorry, this is T. Opportunity and threats are normally external to the organization. And these threats are basically nothing but our risks. Similarly, our weaknesses are our risks. Documentation reviews, that could be agreements, could be business cases, or organizational process assets. They could be one source of identifying the risks. Similarly, the prompt lists. We talked about the prompt lists. Anybody use prompt list before?
Hi. Sorry, I just managed to get back.
Yeah, sorry, Grace. It took more than anticipated and it took a lot of time. I don't know, they were asking too many things, including GST and so on and so forth.
Okay, it's all good, guys.
You didn't pay any risk on that.
Yeah, true. So I really couldn't identify the risk because they didn't notify me that subscription is ending today or something like that. Prompt list. Yeah. Anybody use prompt list? it is like already prepared list with the major categories of the risks, and it helps us to trigger or prompt ideas in our mind. And then facilitation related to risk meetings, or meetings that only focus on the risks. Output of identified risks, risk register. This is very important document, very important artifact. It's a living document. It is first generated when we start identifying the risks. Normally, a risk register is a big sheet where we have multiple columns that talks about different risks, their description, potential risk owners, potential risk responses. Remember guys, we are at our second process where risk register is going to be developed, but it is a living document. As we will go to further processes, our risk register will keep on populating. More and more columns will be keep on adding. During this activity, this process, initially we normally have a list of risks, 1, 2, 3, maybe up to 200 risks. The description of each risk, and then we may have the origin or the source of a risk, our major categories, scope, schedule, cost, or external, internal, commercial, technical, or unforeseeable. It depends on us. During planning, we decide that what categories we are going to use. Sometimes even we can use categories based on work packages. Risks related to work package 1, related to work package 2, so on and so forth. Risk related to work package 100. So by doing this, we are able to identify risks for each work package and then focus on each work package related risks. Similarly, in this risk register, we normally have potential risk owners, the people who are responsible. If risk will come, they will take the actions. We may even have the potential responses. Remember guys, we didn't do the analysis. We really didn't determine the actual response, but we might put some potential responses. For example, buying insurance, so on and so forth. We also identify the root causes of the risks or the origins. Okay, as I previously mentioned, and we may have risk categories that were initially identified during the planning stage. The second output for this process is the risk report. In PMBOK version 5, risk report was not an output of this process. This is a newly added output by PMI, and the purpose is to represent our risk related effort in the form of a report for our stakeholders, so that they can see that how much effort is being put in risk related activities. Once risks are fully identified, the next step is analyze those risks. We can analyze using qualitative risk analysis. We can also do it using quantitative risk analysis. For most of the projects, we only do qualitative risk analysis. For some projects that are very risky or that are very, very important, or where the human life is at stake or our essential money is at stake, then we may go for quantitative analysis. However, quantitative analysis is time consuming. It is expensive as well. So therefore, for most of the standard projects, only qualitative risk analysis is enough. When we do the qualitative risk analysis, we talked about the probability and the impact of each risk on the project. By doing that, we are able to know that which risk is more severe, which risk is more probable, which risk requires a response, which risk could be just ignored for the time being, for example. By doing the analysis, we are able to prioritize our risks. We identify risks in the previous process. Now the next step is prioritize the risks. Because for example, if we identified 200 to 400 risks, we might not be able to create plan for all the risks, but only for high priority risks whose probability and impact is high. We can determine the probability, we can represent the probability and impact either using low, medium, high scale, or could be a range from 1 to 10. Okay. And we can do this thing for both probability and impact. Another activity that we do while doing our qualitative risk analysis is we do the assessment of our risk related data. If data is of quality, it is reliable, and we can say that data integrity is fine, then qualitative analysis would be much better as compared to when data is not available or quality or reliability of data is doubtful. So data quality assessment plays an important role for better qualitative risk analysis. Any question about this?
Does it represent a different line or column?
Risk data quality assessment?
Yes, if you rate it for how you think how accurate it is, or you just take that into account when you're assessing?
Yeah, we take into account. We don't put it in the risk register. So we conduct this assessment to look on the data available and how much data is available. Maybe we really have very limited data available. That might result in not a good qualitative analysis of the risks, but we don't put a separate column.
Okay, thanks.
Yeah. While we are doing the qualitative analysis, our categorization that we are doing since planning stage, planning of risk management, we keep on updating it and we keep on adjusting our risks into different categories. Why we put it into categories? Either they are like knowledge area wise categories, either they are like external, internal, or commercial type of risk categories, or they are work package wise categories. We always keep on updating the risks by putting them into more relevant categories. Why we do it? Because sometimes by creating just one plan, one risk response, we can eliminate multiple risks into the same categories. Just eliminate one cause, it will improve multiple components in our risk register. An example of probability and impact and how it could be calculated is shown here. You can see a grid. On x-axis, on y-axis we have probability. We denote it with the P, and impact we denote it with I. And based on probability and impact of the risk, we put them into different cells. Think of this range in terms of words or its interpretation. If probability is only 1 to 2, it's a probability is low. 3 to 4, probability is medium. 5 to 6, medium high. 7 to 8, there is a high probability that risk must come. In fact, 7 is nothing but 70% of the probability, isn't it? If probability is 70%, an action is must required, 70% or above, okay? And if probability is 9 to 10%, it is just like a fact. On the other side, severity, impact or seriousness, its rating is given here. Grace, can you please help me to read the rating for seriousness or impact?
Rating. 1 is no real impact. 2, small reduction of time or cost reserves. 3, medium reduction of time or cost reserves. 4, large reduction of time or cost reserves. 5, slightly over budget. 6, over budget by or project delayed by 10 to 20%. And 7, over budget by or project delayed by 20 to 30%. 8, over budget by or project delayed by 30 to 40%. 9, over budget by or project delayed by 40%. And 10, project failure.
So you can see that as rating is increasing, initially our reserves will take care of them. But issue come when we go over budget or above schedule, we are delayed. And when this thing happens, we need to be more careful. In fact, what happened is in the previous slide, here you can see, we determine the probability and impact of each risk, and based on that probability and impact, we give grade to our risk. For example, if impact is 9 and probability is 8, in that case, for example, our grade is A. Okay. If probability is 9 and impact is 10, for example, think of our grade is A. For example, probability is 5 or 50% and impact is 6. In that case, you can think of, oh, okay, our grade is B. So based on these grading, we can see high priority risks, medium priority risks, low priority risks. So this grading could be, for example, A to F. A is high priority risks, more critical risks. F could be low priority risks, and we might even ignore them. We normally call them residual risks. These are the risks which are like, we will keep on monitoring them, but we are not going to prepare a response for them. Risk parameters, when we are doing qualitative analysis, we consider few other parameters as well on top of probability and impact. For example, urgency, that is about timing. If it is going to be occur straight away, then we need its priority would be high. Dormancy, that talks about, okay, risk occur here on day 4, but its impact is realized on day 10. Just think about, we pour the concrete on day 4, but we really cannot determine its quality or its strength until it becomes dry or until we install something on top of that concrete. And that could be on day 10. So this is dormancy. Manageability and controllability. Few risks are comparatively easily manageable or controllable, other are very tough. We adopt different strategies based on different risks parameters. Similarly, we also look on the strategic impact of a risk or group of risks or the overall risk on the project objectives or the organization's objectives. Output of qualitative risk analysis. We normally get an update into the assumption log, issue log, risk report gets updated, and most importantly, the risk register updates. As I told you, it's a living document. Okay, more and more columns are being added. For example, the risk ranking for the project is determined and compared with the other projects. It helps us to determine the overall risk for the project. One project could be like only 30% risky, another project could be 60% risky, and we might need more reserve in terms of schedule and time. Similarly, we get our risks prioritized. We get the rating for the probability and impact, and based on that rating, we determine the grade for each risk. We also do consider other parameters while doing prioritization for the risks. We group the risks by categories. In fact, we do the update into it because this work is already done. We also list the risks, especially the top risks. For example, top 20 risks for further analysis. For example, quantitative analysis that we are going to do in the coming section. In fact, this is a very important output of qualitative risk analysis. It gives us an idea or help us to make the informed decision, or we are going to invest more money and time on further analysis on the risks or not. Are we going for quantitative risks or not? Maybe we are not going at all. It's more than enough. Enough risk management is done. Or maybe we are going to do it for few top risks, which are like pure risks, so on and so forth. So maybe top 1 to 20 risks, we are going for quantitative analysis. Rest of the risks, for example, 21 to 200, we just prepare a response for those risks based on our qualitative analysis. And rest of the risks, for example, 201 to 250 risks, for them, we are even not going to prepare a response because probability is too low, impact is too low. Why we need to spend more time on them? These type of risks are called non-critical risks, and we just put them in the watch list. We don't create a response for them. Based on our qualitative analysis, we do quantitative analysis. Quantitative analysis is fantastic. It gives us deep insight, but it is complicated, it is time consuming, it is costly, it is based on the actual numerical data. And also here, the quality of data and availability of that data is very important. And the purpose is again the same, to determine the probability and impact. But now probability and impact won't be in the form of a range or low, medium, high. It would be in numerical digits. Normally, we conduct quantitative analysis on high risks or their grades are high. By doing the quantitative risk analysis, we are able to find which risks require a response, what is the overall project risk or risk exposure. We use this terminology, risk exposure of a project. Could be 50%, for example. We determine the probability and impact in quantified manner. For example, it helps us to determine that we are going to meet our project objectives. For example, these are 5 key objectives of our project. It can give us a very good idea that there are 90% of the chances we are going to meet all the 5 objectives. 95% of the chances that we are going to meet all 4 objectives. So it is that much in depth. Even it can help us because we are talking in real data, numerical data, real money, so on and so forth. It helps us to determine cost and schedule reserves. Based on real calculation, we are able to find that, okay, these are 200 risks, and we identified that for these 200 risks, to manage these risks, we require $100,000 exactly. We require 2 weeks exactly. It also helps us to identify those risks that need more attention based on probability, impact, and other risk factors. It also helps us to create realistic schedule, realistic budget. In fact, it helps us to tell, okay, if we want to complete our project on 27th of December 2020, okay, that's our aim. How much are the chances based on the activities, based on the risks, based on the estimations, okay, based on the uncertain event, how much are the chances or probability that we will be able to complete on 27th of December? Maybe it is 85% chances that we will complete on 27th of December. And what about completing this project on, for example, 5th of January? Okay, this is like 88% chances that our project will be completed on 5th of January. So this type of numbers, this type of figures, quantitative analysis can give us. While we conduct quantitative analysis, we take these inputs into consideration. For example, the plan and the scope. From scope, we get our project objectives, project deliverables, and work packages. Schedule, very, very important input. Most of the quantitative data come from schedule and cost. Activity start date, end date, durations, their criticality, mean if they are on the critical path or not, path convergence, path divergence, so on and so forth. Project performance, and also based on that performance, the 4 costs. The risk register, because all the risks come from risk registers, and the risk reports. All those things that are already produced can help us to conduct a quantitative risk analysis. We can use a variety of different techniques on quantitative risk analysis, including expert judgment, data gathering techniques, and I believe most of you are well aware what could be the different data gathering techniques, data analysis techniques, interpersonal and team skills, representation of uncertainty, cost and schedule estimates, and use of historical records from previous projects. Another technique that we use for quantitative risk analysis is Monte Carlo analysis. It is just like playing in a casino. We do the same things. We run Monte Carlo simulations again and again to get a realistic outcome. What happens is, once we have schedule, once we have risk-related activities, once we have, especially if our schedule is based on 3-point estimate. You remember 3-point estimate? Optimistic, most likely, and pessimistic. Okay, it could be weighted average. It could be just standard average. Weighted average is PULT. Standard average is just our 3-point estimate. It takes data from here and determine by running computer simulations, because you cannot calculate it by hand. It's not easy. Maybe for 5 activities you might find it, but not for 5,000 activities. So computer and also MS project, does it help to do Monte Carlo analysis, Myra?
We haven't actually tried that, Vice.
Yeah, but we can try it. We can consider worst case scenarios, best case scenarios, and these estimates. It help us to determine that, okay, when our project could be completed, how much money would be required, what is the probability of completing a project on a given time, so on and so forth. It also translate these probabilities and impact into overall project exposure or overall project risks. It use network diagram. So this is one of the techniques that help us to do the quantitative analysis. Another technique is sensitivity analysis. But it talks, sometimes we also call it tornado analysis or tornado diagram. We use this technique to find out which risks are more sensitive. For example, if you look on this diagram, it's just like a tornado where more sensitive risks are at the top and less sensitive risks are at the bottom. What it is showing that, okay, we are going to do one activity, server installed by November 10. If they are installed by November 10, we will get this benefit. Okay. And if they cannot be installed in November 1, we might have this impact. Similarly, data security test, if we will do it, we will get these advantages. If we will not do it, we will be hurt by this much of the money, so on, so forth. So this is tornado analysis. It helps us to find out how one decision will impact on the project. If we will make one decision, what would be the impact? If we make another decision or opposite to that, what would be the impact, so on and so forth. But important thing to note down, high risks whose impact is high, they are on the top, and low risks, they are at the bottom. I got this question on the exam. Decision tree analysis. Everybody use decision trees, isn't it? Anybody use decision trees?
Only in basics, really.
Yeah, so decision trees basically help us to see the impact of making one decision or its opposite decision. Maybe let me open something so that we can discuss about decision tree in more detail. I'm just opening a document that might help us to discuss the decision tree. It's almost there. Can you see the screen?
Yes.
Yes.
Yeah.
Okay. So this is one simple decision tree. For each decision, you can make this tree. For example, okay, for the project we are going to do, are we going to develop its prototype or not? Decision could be yes or no. For example, you go for the yes, it will cost you 100,000. If you're not developing a prototype, what would be the cost? 0. Okay. Now let's move next. If you develop a prototype, the chances of success is 70%. Chances of your product success because you developed a prototype. Okay. And payoff would be around $500,000. And chances of failure is 30%. And the failure cost is around 50,000. By doing that, what can you do is you can determine the value of each path. You can see this is one path. Prototype or not, prototype, success, payoff. And then what you are getting? 350,000. And then you determine the value of next path. How much it will cost you? 30%. 30% is what? Nothing but our probability, isn't it? It is our P, chances. And what is cost? It is the impact. Okay, so the value of risk is calculated probability into impact. Here, the risk would be around 30% into 50,000. That is 15,000, isn't it?
Yeah.
Yeah.
On the other side, look, if we don't go for prototype, the chances of success is only 20%, whereas chances of failure is 80, and it will cost us around 250,000. Again, these are random values. You have to do calculation for your decisions by yourself. And if you calculate the risk for this path, it would be 80 into 250,000. That would be around 200,000, isn't it?
Yeah.
By doing that, what can you do? You can determine the severity, or we normally call it expected value, expected monetary value, EMV. You can calculate the expected monetary value of each risk. Risk 1, 30% into 50,000. That would be 15,000. So 15,000 for risk 1, 2,000 for risk 2, so on and so forth. And at the end, if you aggregate the whole number and you, for example, total it to 200,000, this 200,000 is your contingency reserve in terms of money. And if you want to calculate it in terms of schedule, you can also calculate it in terms of schedule. If you're calculating it in terms of money, it is called expected monetary value. If you're not calculating it in terms of money, but into any other units like schedule or just a random impact value, in that case, it is called EV, expected value. It is different from earned value that we study during earned value analysis. Okay, so we can use the decision tree analysis to determine the amount of schedule reserve or cost reserve. Any question?
No.
So this fact is given here. Expected value is nothing but probability into impact, and expected monetary value is again probability into impact. However, this impact is given into in dollars. Output of quantitative risk analysis is again update into our living document, that is risk register. Here we will have the high value risks, top priority risks with their quantified probability and impact. We also can get quantified likelihood of meeting the project objectives. This project will achieve its objective and the likelihood is 70% or 80%. Trends in quantitative risk analysis that talk about that what are the chances as our project is moving on, what is the trend. We also find out contingency reserves in terms of time and money. We also find out the overall exposure of our risk exposure of our project. We can get realistic and more achievable schedule in the budget by doing quantitative risk analysis. And based on that analysis, we can later develop our risk responses. What are risk responses? This is a risk, what to do with it? Do we need to take action straight away, or we should prepare an action, and once risk will come, then we will apply that action? Or we need not to take any action at all because probability and impact is much less. So this is finding ways through which we can reduce the risks which are negative and increase the probability and impact of those risks which are positives. For each risk, especially if we talk about negative risks, the first step we try to do is eliminate the risk, fully eliminate it. If it cannot be eliminated, reduce the probability and impact of that risk. And if we cannot reduce the probability and impact or eliminate the risk, then prepare a response. If risk will come, how to apply that response. And also sometimes, if our response doesn't work, our contingency plan doesn't work, do we have any other plan at the back end? Like we normally call it fallback plan. All that work is done when we are planning for the risk responses. Any question here? Yes, please.
No, just saying no.
So for negative risks, few strategies are given here. For positive risks, other strategies are given here. If risks are threats, we try to avoid or mitigate, reduce the probability and impact, or transfer it, for example, to our contractors who are expert of this domain. They will come and do it, and we pay for that from contingency reserve. Escalate it to our senior management or to the client. Or if there is no chance that we can avoid or mitigate, then sometimes we have to accept those risks, and normally we try to determine the workarounds if risk comes. For opportunities, we try to exploit our opportunities. It is opposite to avoid. If we cannot fully exploit it, we try to enhance their probability and impact. If we cannot exploit or enhance for our projects, we can share with other project teams. They might use it, or we can escalate to senior managers. Maybe it could be of their use. And if opportunity is just there, you need not to do anything, then just accept it. Once our risk response are prepared and added into the risk register, our risk register may have these entries. Residual risks. What are residual risks? I just explained it.
They're the very low risks that may not warrant a response.
Yes. Secondary risks, we didn't discuss about it. They are those risks which are newly generated risks. For example, there was risk 1. We applied a risk response on it. See, risk responses could be implemented by many different ways. Sometimes if risks are very, very high, their grade are high, we apply the risk response straight away. For example, if we are going for procurement from overseas, then insurance could be one way. Or if we want to reduce the delay risk, then maybe air cargo could be one way. Once we take that action to mitigate the risk or avoid that risk, there could be chances that, okay, our risk could be reduced, or there might be no impact on the risk at all, or our risk increases based on our response. And sometimes what happens, a new risk is generated. Three things may occur when we apply a response on a risk. Oh, sorry, four things. No impact, risk reduced, risk increased, or a new risk is generated. This new risk is our secondary risks. We also get our contingency plans, fallback plans in case contingency plan doesn't work. Risk triggers, we identify the risk triggers. We get the contracts in case if we are transferring our risk to the contractors. We find out the risk owners who are responsible for the risks, and we determine our reserves in time and money. Then when risk response is done, our planning is completed. Next stage is implement the risk response. We can implement the risk response straight away as per our plan, or we may wait for the trigger that risk triggered, and then we implement the risk response. This is heart of risk management. Here we do the actual work. Risk implementation and risk monitoring, it goes together, because executing and monitoring is like they normally run together. Here, project manager and the team members are the risk owners. They keep on tracking and monitoring the risks. They also keep on looking on risk triggers. If there is a need to change, even in the risk trigger, they also change it. Also, during monitoring, if risk comes, there is no contingency plan, no fallback plan, the risk is unforeseeable, then sometimes we have to find workaround. These workarounds are unplanned responses. During monitoring, we normally have risk-related meetings where maybe in a month's time or in 3 months' time, we sit down, look at the risk register and reassess our risks. It helps us to reassess our contingency reserve as well. And this reassessment of contingency reserve is called reserve analysis. How much money is left? How many risks are mitigated? If money is enough to mitigate rest of the risks, or do we need more money? Or there is some money that we can return to our sponsor. During monitoring risk, we also do the technical performance analysis. In fact, I just told you what is technical performance analysis. It is talking about, okay, these are dollars and these are risks. And as risk decrease by spending the money, we keep on doing the performance analysis and see that, okay, if our contingency reserve is meeting our requirement or not. If contingency reserve is more or less than our requirement, etc. And this thing is done in the meetings. We might also have some risk audits or risk reviews too during monitoring. As an output, we get work performance information based on our data analysis and data assessment, updating the risk register, change requests, and updates into the project management plan or OPAs. This was all about risks. We cover a lot. We cover 7 different topics. But before Going in depth, before finishing, let's quickly review what we discussed today. Grace, can you please help me to discuss the key concepts that we covered today?
Value and risk balance.
We do this work at the time of planning. We really see that based on our risk appetite, risk tolerance level, and risk requirements, and what value we are getting by doing the risk management, all those things are done at the time of risk management planning. How much time we are going to put, how much money we are going to put on the risk related efforts, everything we do during the risk planning. Next.
Project risk management linked with project success.
Yes, that's a fact. Our schedule, our plan cannot be completed without risk management plan. It is must component of our project management plan because it helps us to complete our project successfully.
Individual and overall project risks.
We talked about both of them. By doing qualitative and quantitative risk analysis, we identify probability and impact for each individual risks, and we also find out the risk exposure for the overall project. We also talked about positive and negative risks that could be individual, could be overall. We have also seen that our risk register is continuously reviewed and updated. It is just like an iterative process. We also had a look at risk appetite and threshold, and we determined the difference between appetite and threshold. Appetite is a range and threshold is a point, a specific point. And then emerging practices. Sukanya, is she around?
Yes, sir.
Can you help me to read through trends and emerging practices?
Yes, sir. Trends and emerging practice. Project risk should be understood in wider context. Event and non-event based risk. Non-event based risk. Variability and ambiguity risk. Project reliance and integrated risk management.
So, we just not only focus on like small set of risks. We should think risks on an individual level, on a group level, and on the overall project level. We not only think about events, risk events that may occur, but also non-event based risks. As example is discussed previously, that could be variability risks and ambiguity risks. Also, we may think about project resilience. How resilient is the project? And also integrated risk management, where we see the impact of our risk management and its related activities on other knowledge areas of a project management. Relevant considerations while we are doing our risk management or planning for risk management activities, following factors determine that how thorough, how detailed our risk management activity would be, including project size, complexity, importance, and development approaches, sequential or risk-adjusted backlogs. We are going to discuss risk-adjusted backlog in the coming slide. It is an agile concept, whereas sequential is as we just discussed in the previous slides. Agile. Tanya, can you please help me to read through it?
Agile is run certain projects, frequent reviews of incremental work products, cross-functional project teams with increased knowledge sharing, and risk-adjusted backlog, so a living document.
Okay. Proposition of risk on Agile is something like that. For waterfall, risks are decreased over the period of time. Okay, as project goes on completion, risks keep on decreasing. On the other side, in Agile, we believe that if there is a bigger risk, we will target it early. We will see, we will go and face that risk, and we will try to mitigate it, reduce it, eliminate it, so that either we will fail fast or we will be succeed. Fast failure is not a problem at all. It helps us to spend our energy, time, and resources on something better. So the proposition of risk is like this in agile environment, where most of your risks, which are like on y-axis, and this is time, most of your risks are reduced or vanished early in the over the timeline. Also, frequent reviews of incremental work products help us to get our deliverable, our features, our user stories accepted by the clients. If they're accepting our user stories, mean risks related to those work packages, those user stories or features are going down and down. And we are getting continuous feedback too that help us to reduce the risks and fulfill customer or stakeholder expectations. Another thing is dedicated teams, cross-functional teams, reduced bottlenecks, T-shaped professionals, and teams coming from all different departments with increased knowledge sharing. All those things help us to reduce the risks. And most importantly, we always have risk-adjusted backlog. I believe everybody now familiar with the backlog. Backlog is just one document. They are not multiple documents. That's one thing to remember. All the work that we need to complete, all the features that we need to complete, they should be in one document at one place, and we always work on that one place. Previously, we talked about backlog. It's a responsibility of product owner or manager. All the user stories and features are here given. Okay, this is, for example, one user story. This is another user story. This is another user story, and they are ranked. They are prioritized here in this backlog. For example, 1, 2, 3, and normally they are ranked based on their value. For example, a user story, it is of $10,000. Okay, it's worth. Another user story, it's worth $8,000. Another user story, $5,000, so on and so forth. Based on their value, they are normally prioritized. This prioritization is done by the product owner. However, where teams run the sprints, you remember the sprints? The iterations, 2 weeks iterations?
Yep.
Similarly, they also run the spikes. What are spikes? They are shorter than the sprints, and their purpose is focused on many different things. Just to check the feasibility of the architecture or feasibility of the design, or focus on the risks, so on and so forth. Normally they spend 1 week, for example, on identifying the risks, analyzing them, and mitigating them. So this concept is called spikes. Okay. During spikes, they are able to determine the value of each risk. For example, they identified multiple risks. I'm saying risk 1, excuse me, just let me change the color for better understanding. Risk 1, and they determine its value. You remember P into I, but into dollars. For example, value of this risk is 9K. If we will not mitigate this risk, it will charge us 9K. Risk of value of risk 2 is, for example, 7K, so on and so forth. What we do? We put these risks here. into our backlog. What we do? We firstly complete user story, then we mitigate the risk or eliminate it. We work on that because 9K value, okay? And then user story to 8K, risk to 7K, so on and so forth. This concept is called the risk adjusted backlogs and normally used in agile way of working. Any questions?
No. For me.
Okay.
Yeah, so it was the end of the session. We will have our last knowledge area, that is procurement management, tomorrow, and then we will discuss different questions. I'm stopping the recording and